Alright, so this is my project called Terrific, which sounded a lot cooler in my head. This is a tool that's supposed to help you learn linear algebra. One of the concepts in linear algebra is called finding the reduced row echelon form of a matrix. And you do this through elementary row operations like swapping, scaling, or pivoting. So this is a tool that's supposed to help you learn and help you try to understand what these things do. I've realized that I haven't actually put what exactly RF is on the page. So the prerequisite is that you kind of already know what you're trying to do. But I suppose that's one part I should make more user-friendly. So one thing I did really like implementing is that you can mouse over the matrix elements and they like highlight and then fade out. It's just fun to play with. But I am proud of this info box that whatever you mouse over, you are able to see what it does. And you can have an explanation for each of these row operations. So I did have a lot of fun making this. It was a lot of work, but originally I was going to make a game that was based off of this, where you would try to solve a matrix in a certain amount of moves and within a certain time limit, but I just removed the game aspect. I might come back to this during the break or something. I'll talk more about successes. So I used the math.js library for its one feature, which was to parse numbers. And so here when you're scaling a row, which you can look at this row, you can scale it by factors of, let's say, 2. But using math.js, I made it so that you can't scale by something that's not a number. So you can type in expressions like something like that, which should evaluate to 1/8. You can like go crazy with it. But if something's invalid or if it's 0, then you can't actually do anything. So I'm really proud of that. I really like that. Even though it was really, really simple, it was just like, okay, I'm just going to call this function from the library. But I think it helps a lot with the user experience, because otherwise, yeah, this would not be valid. So also, I implemented these 2 algorithms. So number 1 is checking for reduced row echelon form. There's 4 conditions that you need to meet, and I wrote an algorithm for that, as well as this here, which actually solves the matrix for you. And so you see here, this is the reduced row echelon form. If you go to a more complex matrix, you can see it in action. It's pretty hard to follow. That's something I could think about. Maybe if a person wants to see how they actually solve the matrix, maybe I could implement something that says, here's step by step, here's how you would do it. But for now, it just ticks through it, so you can kind of see it in action. And eventually, it'll get to reduced row echelon form. All the buttons are disabled while you're doing it, so you can't click anything while things are happening. But when it's done, then you can start clicking things again. You can also generate a completely random matrix. If you mess up, you can actually reset the matrix. So I can swap a couple of rows. This resets it to the original state. Yeah. And if you've already noticed, but the text also does change whenever you perform a row operation or when you click the auto reduce row echelon form. And that helps you see what exactly changed. I think Travis suggested that I would just literally have the rows move, but I didn't figure that out, so I just went for this, which I think works pretty well. It tells you what it's changing. And so all of these matrix operations, I'm pretty proud of, because all of them are implemented by hand. So all of the row operations that you see here, like the swapping, scaling, pivoting. I thought I was going to rely on the library, but the math.js library didn't actually have that functionality. A couple of setbacks. So I really shouldn't talk about this because it's on the rubric that there shouldn't be any visual errors or something. But here's a visual error where if you move between the moves fast enough, something's wrong with the CSS where the border kind of like stays behind for a second. And I think that has to do with how hovering and scaling works. I don't know how to fix it, so I didn't bother. But a bigger issue was with floating point numbers. There's actually a lot of workarounds that I had to deal with. I tried to use a library called decimal.js for more precision, but it didn't really help because I didn't use the library everywhere. So as a result, I did have to do a couple of workarounds where, if you try to scale by a really small number, it won't let you. Well, that's not really related to floating point error, but that is a feature. But if you mess around enough, sometimes it causes some weird errors where you'll have numbers that they just scale very weirdly. They have decimal places, and so I implemented some workarounds where if you have a very small number like 0.00 or something, it will just set it to 0. Whenever it checks for reduced raw echelon form, it will just get rid of some numbers that are kind of close to 0. If you round up, if you scale a row or do something and the number ends up being very close to a whole number, it'll just round up or round down. Just a couple of these things. And yeah, so that was my primary setback. There's another one I had where these elements would just overflow down the screen, and I had to use some JavaScript and a flexbox. Praise the Lord for flexboxes. So yeah, so that's my project. It's a lot of fun just to play around with, and I really love actually just watching the automatic RF finder. And yeah, you can also hear there's sound effects that I got off the internet. They're all on the documentation page. So yeah, hopefully you enjoyed this demonstration and hopefully you try it.